All right, for everyone watching on YouTube, welcome. This is our 13th live stream geometry session, and it's already the beginning, and we have 5 other people here with us. So I also posted a video last night on really cool problems, so feel free to check that out. All right, so I'm going to get started on the problems for today. These are from the Indonesia team selection test. So let me share my screen. Here we go. You guys can all see it, right? All right. So let me maximize it. So we have 2 circles. So this is a 2-circle problem. They intersect at points A and B, and one passes through the center of the other. So I'm going to try to draw it like this. And then I'm going to let O be the center. Okay. I can hide point C. And then I will draw the circumcircle of AOB. That would be the other circle. All right, so K1 is the smaller circle. Maybe I can make this a little bit bigger. This smaller circle is K1. Line P intersects that circle at O and K. Let me draw that line. So I can call that point K. And it also intersects K2 at points L and M. So L is this point, and M is that point. Okay. And P lies on AB such that LP is perpendicular to AB. Let me draw it like this. And we want to show KP is parallel to the median of triangle ABM. So I'm going to draw the midpoint of AB, which I'm going to call D. And we want to show PK is parallel to MD. All right. This feels kind of familiar to me. I don't know if I've seen this exact problem before, but I feel like maybe I've seen something similar. Let me unhide this just to make things. Whoops. All right. So we want to show MD is parallel to PK. Obviously, OD is perpendicular to AB, right? Let's see. So basically, I think we want to show these triangles are similar, right? MOD and KPL. Yeah, this does look really familiar. Trying to remember. I think that's equivalent, so I'm going to label this point right here. Let's see who we got. Yeah, let me draw the other center. So that would be the center of D. All right. Yeah, maybe we could use ratios somehow. So we need to use that this circle passes through O. Can we show that MO over OD is LP over LK? So MO over OD, that's LO over OD. Let's see. Thinking here. Yeah, this is interesting. So we can basically move K wherever we want. Is it obvious in like a special case? I'm not sure. The coordinate bash. No, I don't like coordinate bashing on my channel. Okay, I mean, in a competition, it might be a good idea though. There has to be some similar triangles here. I know it. Let's see. We want to show. Well, we know PEL is similar to OED, right? Because OD is perpendicular to AB and LP is perpendicular to AB. So we know those are similar. Yeah, maybe we could use that to show. I think that might be pretty close, actually. We need to prove that KPL equals MDO. Oh, in center, X center lemma. I'm sorry, I missed your suggestion. So wait, is this actually an isosceles? No. Triangle KAB. Hey, Rodrigo. Thanks for joining. I'm sorry, I'm just reading through all your suggestions. So Anmal mentioned the in-center, X-center lemma. So maybe L is the in-center, M is the X-center. For triangle AKB, you're saying? Yes. Yeah. I think that might. Yeah, so L is the in-center of triangle AKB, and M is the X-center. Wonder how we can use that. Are there any like cyclic quads? Let's see. We know OED is similar to PEL. Oh, I think this is just power of a point because, wait, OED is similar to PEL, right? And we have MO times OL is, or ME times EL is AE times EB is OE times EK. Yes, I think this is just like power of a point. Let me write this up. So So since D is the midpoint of AB, then OD is perpendicular to AB. And then from there, since LP is perpendicular to AB, then we have similar triangles. So all right. And then, so that means OE over OD is LE over EP. Actually, I'm going to write this a little differently. So yeah, no, I'll write it like that. So P, all right. And now we can use power of a point a bunch of times. So ME times LE is AE times EB is OE times EK. So and then from there we have OE over LE. Yeah, let me rewrite the equation above. So we have OE over LE is equal to ED over EP. Okay, that's just I could have just wrote it like this originally. So then this equation says that OE over LE, OE over LE is ME over EK. Okay. And then if we combine the two, we have ED over EP is ME over EK, which means we get similar triangles. Okay. And so, but also, so ED over EP is ME over EK, and angle MED is equal to angle PEK, so those triangles have to be similar. Okay. That's side angle side similarity. And then from there, it's pretty easy to see that MD is parallel to PK because we have angle PKE is equal to angle EMD. So KP is parallel to MD. And that solves the problem. All right. Does that make sense? Everyone get that? Yeah, I like it. All right, so I will move on to the next one. Hold on just a sec. All right, so this is from 2016. Sorry, I didn't have it teched up, but yeah, Rodrigo, I was just telling everyone I chose 6 problems last night and then my computer crashed. So I chose all these very quickly right before the meeting started, so I didn't have time to check it up. So I is the in-center of ABC. So this one involves an X circle. I'll bet this is probably like a well-known fact, but I don't know it yet. So if any of you guys have seen it, yeah, feel free to let me know. So I is the in-center and gamma is the X circle. Let me put C at the top, just because it might be easier. So this will be, I'll call it C, and then this will be A, and this will be B. So I is the in circle of ABC, and oh, whoops, I actually want, I don't know if this will work. Let me recall this, I don't know, C. There we go. And now I'm going to try to draw the X circle. Where are my rays? There we go. I'm going to draw some angle bisectors to get the X center. And then I'm going to erase some stuff. Okay. So yeah, X circles are always harder with GeoGebra just because they take more space. So then we draw the X circle, and it touches AB at point D. So I'm going to have to rename this D. All right. That's the X circle. It's a pretty nice picture. I'll keep this, well, yeah, let's just do it like this. All right. Let DI meet the X circle at a point S. That's interesting. So when you do it like this, so DI meets the X circle at a point S. And we want to show that DI bisects ASB. I feel like this has to be a well-known fact.
I think there's a well-known fact relating this line DI because it passes through the midpoint of the altitude from C.
Oh, the midpoint of the altitude.
Yes, it is on DI.
Okay, interesting. All right, I'm not going to use that fact, but I will try to prove it if it ends up being useful. Yeah, let me just draw what there we go. All right. Let me draw angle ASB. Oops. Let's see. Looks pretty nice. So yeah, I'll draw that perpendicular line. And you're saying DI passes through the midpoint. Let's see. That don't know for sure that will be useful, but it might be. So let's see, we can use angle bisector theorem. What if, I feel like projective geometry might be useful. Like if I drop a perpendicular to that, then that means I want to show that A, B, B, and H are in harmonic conjugation. Let's see, can you draw the circumcircle of SBC? I can draw that. That's a big circle. Let me zoom out a little bit. Sorry. I'm just going to delete that for now. Yeah, I'm going to delete this point. I don't know how helpful that really is. So it's a well-known fact that, so I'm going to draw this point of tangency to it. I'll call it, I want to call that H. So I'm going to call this K, and I'll call this H. So it's well known that AK is equal to dB. So really, we want to show BS over AK is AS over KB. That's one way we could do it. What if I draw these tangency points? So basically, we want to show that BS over AJ is AS over BF. That's the same as saying that FB times BS is JA times AS. So instead of ratios, that would give us products. Do you think that the X circle, so I'll draw SBC again. So my Tej thinks it's possible that, no, I don't think the X circle can be tangent to this circumcircle of SBC. Because S, IMO 2002 G7. Okay. But yeah, I don't think it's SBC is tangent. Maybe some, let's see. Maybe SBA is tangent. That would be really surprising, but maybe. Is SBA tangent to the X? Yeah, SBA is tangent. I'll have to check out that problem. So IMO 2007, I'm sorry, IMO 2002, apparently they asked to prove that these two circles are tangent, which to me is quite surprising. So then we could probably use, all right. I'm gonna hide it just for now. So let me draw. So AIBE is cyclic, right? So we can draw the circle of that. Let's see, AI. Just thinking here. Let me try this. Now, what if I try drawing like the circumcircle of SAB? Yeah, actually, So I mean, basically, it's saying that if we drew the circumcircle of SAB, which is kind of what Irajan was saying, then it's saying SD would meet it at its midpoint. So yeah, S is the point of tangency of the X circle and the circumcircle of SAB. So if we could show D is the midpoint of so yeah, if I draw this other point right here, is D the midpoint of arc NS? I think it might be. Let's see. No. What was I thinking? Oh, if we draw, yeah, I see how that might. I'm going to erase some stuff for now, just because define the intersection of SB and SA. Yeah, no. So if we draw those points, it's like saying that then OP is parallel to AB, and we want to show D is the midpoint of OP. Yeah. Yeah, OP is parallel to AB, and we would want to show D as the midpoint. So yeah, let me delete the circumcircle of SAB for now. Oh, do you have an idea? Arc DP and DO are equal. That we want to show they're equal, right? Is that obvious that they're equal, or that's what we want to show? Oh, you're saying if we know these circles are tangent, then OP is parallel to AB. So then it follows that ED is perpendicular to OP. So if we know that those circles are tangent, then it solves the problem. Interesting. So can we show those circles are tangent? That is an interesting idea. All right. So let's think about this. How would we show those circles are tangent? Oh, it's a hard problem. All right, maybe let's see if we can find a different way to do this. Because I guess
yeah. Would you just explain why the problem would be finished if you know these circles are tangent?
Sure. So yeah, suppose these two circles are tangent at point S, right? Then by a homothety, OP has to be parallel to AB. Because if you take the point of tangency and you draw lines and you see where it meets, basically it's like if you take the X circle and you scale it about point S, then you get the circumcircle of SAB. So it's like if you take this point OP, if you take the segment OP and you scale it about point S, you get AB. And so OP has to be parallel to AB. I guess, do you understand the parallelism?
Yes, but this implies that it is a bisector.
Yeah, so I'll show you how that implies it. So if OP is parallel to AB, AB is perpendicular to DE, right?
Yes.
So that means that OP is perpendicular to DE. And where E is the center, where E is the X center. And if OP is perpendicular to DE, where E is the X center, then D has to be the midpoint of arc OP by symmetry. Because
Yes,
if you have,
yes, you're right. Yes.
so yeah, it's a little tricky to see, but yeah, let's see. I will still try to see if I can figure out why. So 2002 G7, you're saying, is a pretty hard problem, but maybe there's another way to see it, or I'm gonna still keep trying at it. Let's see. Yeah, we could if we just assume 2002 G7, then we would be done. But I want to see if I can figure out how to do that. Yeah, I'll spend maybe another 15 minutes trying to see if I can prove either that or something related to it. Let's see. All right. I'm still thinking about my idea of trying to show AJ times AS is BF times BS. Actually, what if I draw this circle right here? Hold on just a sec. Sorry about that. Let's see if there is a way to show this 2002 G7. So if no, I don't have a video on this with X circles. I think I have a video on a different one. Number 34. Let me check number 34 for a second. Hold on just a sec. Let me check YouTube. Yeah, that's the one. No, video 34. Hold on just a sec. I have to wait for the ad to play. Video 34 is a slightly different problem with the in circle instead, not the X circle. but I mean, maybe the same idea of proof could be used. It's probably a similar idea, but let's see. MBSI is cyclic. I don't think so. So yeah, let's see if we can use homotopy. Yeah, it's like that other video, but with the X circle. But yeah, there has to be a quicker. Let's see. So if we can show SE for INS, let's see. Oh, IANS looks cyclic. Yeah, it looks like IANS is cyclic. That's interesting. Oh, no worries. Let's see. So angle, it finishes the problem because then ISA equals INA, and that's chaseable. This is really interesting. Okay. Well, how would you find INA? So INA, I guess, is NIE minus NCI. Both tangents to the X circle from C are equal. So Cn is equal to, yeah, I'm curious, write out a little more of your solution. So CNI is congruent to C. Okay, I agree with that. Oh, so that would mean that AS is like parallel to IQ, I think. No, wait.
If we prove that these quadrilaterals are cyclic, then angle ISA is equal to INA, which by symmetry is equal to IQB. Because both the triangles are congruent by symmetry.
So angle ISA is equal to angle IQB, right?
Yeah, and IQB is similarly we prove quadrilateral for IBQS should be cyclic or something. Yeah, IBQS should be cyclic.
All right. Let's see. IBQS. Oh wow! Look at how many cyclic quadrilaterals there are here.
The way we prove for the point INAS, similarly we can write for IBQS.
IBQS, yeah. All right.
So we need to prove that INAS is cyclic.
All right. I'll try to show I and AS is cyclic, and then the same argument would hold for I, B, Q, S. That is a very cool argument. I like it. I'm just going to delete that one just so I can focus on I and AS. Oh, whoops. All right. So how do we show I and AS is cyclic? Let's see. So that's the same as showing angle NSD is angle A over 2. Yeah, there's so many circles, it's confusing. But I think I have an idea. I think it's really just yeah. I think I can do it using an angle chase, proving that NAIS is cyclic, because if we can show angle IAC is equal to angle NSI, that would solve it. But NSI is NSD, which is half of angle NED. I think that does it. Yeah, let me delete this circle right here. All right, I'm going to write this up, but that sounds really interesting. All right, so I've drawn a lot here. I forgot, what was point L? Did I even need point L? I don't know what L is. Okay. So, but yeah, I think Ann Moll's idea works. So I wanted to show, so we don't know NAIS is cyclic. I'm going to prove it. So I'm going to delete that circle for now, but then I'm going to add it later. Oh yeah, this, it's true they're tangent, but I'm going to do it Ann Moll's way for now. But yeah, after the session, I'm still probably going to investigate this idea of showing that they're tangent. So Ann Moll's idea was to show NAIS is cyclic. And we have, let me move the diagram a little bit, just so I can type while looking at it. But so this is point N right here. So we have angle NSI is equal to angle NSD, which is equal to half of angle NED. And half of angle NED is half of angle CAD. All right, so second, because so first of all, yeah, maybe I should write this first. So all right. And so that means angle NSI is angle NSD, which is half of angle NED, which is half of angle CAD, since ENAD is cyclic. And half of angle CAD is angle CAI. So that means if NSI is equal to CAI, then ANSI is cyclic. So this is a shorter proof than I thought. So ANSI is cyclic. And then similarly, so I'm going to draw that circle. And then by the same logic, BQSI is cyclic. And so I'm going to draw that one also. And then the problem can be finished using an angle chase, because then we have angle ASI is equal to angle ANI is equal to angle CNI is equal to angle CQI is equal to angle BQI is equal to angle BSI. So wow, this wasn't as hard as I thought. So that means that DI bisects angle ASB. Or maybe it is hard, but Animal is just a really smart guy. All right. But yeah, thank you both for your ideas. This is a fun one. All right, any questions on it? All right, I'm going to move to the next one. All right, see you, Matej. Thanks for joining. All right, next problem. So this is an interesting one. It says one segment is 3 times another segment. So ABC is a triangle, and then we draw the end circle. We'll just draw the end center, because why not? There we go. All right, so D, E, and F are the points of tangency. AD intersects the end circle at M. All right. DF intersects the circumcircle of CDM at N. Let's see. Oh, they're almost tangent in that figure. Okay, so this is point N. And then CN intersects AB at G. It already did G for me. I like that. We want to show EC is equal to 3GF. So this is interesting. It has like a 3 in it, which isn't that common. Okay. Yeah, I'm thinking maybe cross refuse will be useful. Yeah, it feels a little bit like projective geo. So EC is EB. So we want to show EC is DC. So yeah, it feels like projective geo or Menelaus. So we have CD over BC times BG over GF times FN over ND is 1. see. Ni and E, are they collinear? Almost. Doesn't look like it though. Let's see. Let's see who's still on. All right. So let's see. BGND. Let's see. No, it's pretty close again, but not quite. Yeah, it feels like there has to be some way to do projective geo. So if you project through point N, like B, G, and F go to B, D, and C, but I'd like to have one other point on that projection. So yeah, we also have FG. We could use Menelaus the other way. So FG over BF times BD over DC times CN over NG is 1. And FB is equal to BD, so that simplifies things a lot. So basically, I think we want to show CN is 3NG. Yeah, we want to show CN is 3NG. Let me just try to check that. 1. Whoops. That's 1, 2, 3. That is what we want to show. How do we show CN is 3NG? Let's see. Take midpoint of CG and prove something. Sounds like an interesting idea. NM equals NG. I think NM is longer than MG. We could try it out though.
No, I mean M being the midpoint of CG. Then we can try proving NG. We will take it as K, something like that.
Yeah.
Then AGK should be isosceles, something provable, I guess.
So yeah, like you take the midpoint of CG and you want to show that N is equidistant.
Midpoint of GH.
Yeah, I think that's a good idea. Let's see. Yeah, maybe we could show.
And AH looks parallel to FN. I don't know why.
AH looks parallel to FN. Or MH, maybe.
Or yeah, maybe MH. MH is a better option.
Yeah, MH does look parallel to FN. Let's see. Urijan, EM. You're using Ptolemy. So basically you're saying, oh yeah, it's a harmonic quadrilateral. Actually, yeah, so you use Ptolemy to figure it out, but since the tangents at E and F and MD concur, we have FM times ED is FD times, yeah. All right. Yeah.
And is FM parallel to DX? Maybe mix. No. I don't think so now.
That,
no.
yeah. But FD and MH, that's interesting that those are parallel. Oh, I don't think those are parallel.
Oh.
Yeah, they're not necessarily parallel, FD and MH.
Oh.
But it's close. Menelaus. Hold on just a second. CD. So, John, can you write out your idea in some more detail? So yeah, how do we show CN is 3NG? Let's see. MCD, is it similar to MNF? So I see why one of the angles are equal. Is that true? I don't think, let's see. Angle MFN is 95, MDC is, oh, I was wrong. So MFN is equal to MFD. So you're saying MFD is equal to MDC. Oh yeah. So yeah, MCD is similar to MNF. I see that.
No.
Let's see. So FN over CD is FM over MD. And then is EF over 2 ED. I think I see what you're doing here. And then, okay, I think Irajan has a solution. I'm just thinking through it in my head, and then I'm going to write it up. FN. Let's see. So FN over CD is EF over 2 ED. So Urajan, do you think that your idea, do you see how to solve the problem till the end using your idea, or that's like a step forward? Okay, so I'm trying to think through Urajan's idea. So Urajan says that FN over, and I see how he gets it, FN over CD is Fm over Md, which is EF over 2 over ED. So John, can you write out how you use Menelaus, like to solve it off, to finish it off? Let's see. Okay, so MCD is similar to MNF. I see why that's true. Okay, CG. Okay, I'd seen that. F. So, oh, wait, CG over GM times FN over ND times DB over BC is equal to 1. Ah, you're using Menelaus in a slightly different way than I was thinking. Hold on just a sec, let me think about that. So, all right. So Fn over Fd. All right, so I'm going to write out what John has said. So first I'm going to start out using Menelaus. So actually, let me just make some more room here. Oops. So by Menelaus, we have CG over GN times Fn over Fd times BB over BC is equal to 1. All right, and then MFD is similar, or I'm sorry, MCD is similar to MNF. That's an angle chase. So let me make even a little more room here. So, sorry. So we have backslash. We have angle MNF is equal to angle MCD, and also angle MFN is equal to angle MFD is equal to angle MDC. And so MCD is similar to MNF. And then, so we have Fn over CD is equal to Fm over Md. And we can also, FMED is a harmonic quadrilateral. So DEMF is a harmonic. I'll write that on the next line. EMF is a harmonic quadrilateral. And so that means that Fm over, so, I mean, one way to say it is that, just thinking about the best way to do it, but that means that Fm times Ed is equal to Fb times Me. But then by Ptolemy, the sum of these two is Md times Ef. So okay, so by Ptolemy, I'll bet this is a pretty long solution, I feel like, but it's still, I feel like it tells you a lot. I kind of like it. So that's Md times Ef. But those two things in the beginning are equal. So that's 2 what am I doing here? 2 Fm times Ed. Wait a sec. Yeah, 2 Fm times Ed. And so that means that Fn over Cd. Wait, hold on a sec. Yeah, so that means that Fm over Md is equal to Ef over 2Ed. So we have Fn over Cd is equal to Ef over 2Ed. So we could use that fact. I'm trying to see how this finishes the problem though. So okay, I'm going to substitute. I'm going to combine this with this equation. So well, first I'll write this. So if we combine this equation and this equation, we get Fn is equal to Yeah. MD times no, Fn would be CD times EF over 2 ED. And then we could take this and we could substitute it into the original equation. Let's see what cancels. So trying to see how this would work. Yeah, so we'd have an equation with DF, EF, and DE all in it. And also CD, BC, and BD. So yeah, there's a couple calculations left. Yeah, I'm just thinking how to do this. So it seems like this should be enough to solve it, right? So I'll write this. Whoops, sorry. Wait, did I just erase? Whoops. Didn't I write something else here? I think maybe I deleted it. So that's CD times EF over 2 ED. And now I'm going to plug that into the original. So basically that means that's CD times EF times DB. Over 2EF times FD times BC. So yeah, we want to show that this thing is a quarter. So we want to show CD times EF times DB is half of, oh, the EFs cancel. Wait a sec. FN. Oh, I'm sorry, this should be ED. Yeah. ED times FD times BC versus EF times CD times BD. It's interesting. Let's see. Yeah, it looks like this. There's got to be some trick to simplify this, right? Yeah, it's a very symmetric expression. So yeah, maybe there's some similar triangles we could use. Let's see. So yeah, so I mean, BD, if we combine BD and FD, that ratio is like, it's like sine B over 2. And then we have like a sine B over 2, a cosine B over 2. And then we'd have like EF over BC, which to me isn't that obvious how we get that. Do you guys have any ideas? Is there any trick way to finish this up? Seems very close. Hmm. All right, let's see. Yeah, I'm just trying to figure out how to use EF in an equation. Let's see. I feel like there's got to be a more like intuitive way to show that EC or to show that CN is 3GN. Hmm. Just thinking. Yeah. So I think, is EDF similar to the triangle formed by the x-centers of A, B, and C? I think it is. Yeah, so everything here can be written in terms of trigonometry, right? So I think this should, because EF, actually, I'm not sure. Does everyone think this is right? That I didn't make any mistakes here? I think it's right. Let's see. Oh, you figured it out? Okay, so you got the same thing I got. Okay, yeah, so you got the same expression I got. It's just a matter of how to simplify that. Yeah, if the problem is true, then it should be equal to 4. Let's see. Yeah. So yeah, we can basically, like if we use Ptolemy on AFIE, we have EF times AI is equal to 2AF times the radius. Although there's better ways to do it. Yeah, let me see. What if I tried using the IM lemma here? So basically we know this is going a different way, but if we take the midpoint of BC, then IJ bisects AD, right? I'm not sure if that helps. Does anyone see a way to simplify this? Let's see. Not sure. Let's see. I'm going to delete point H for now. Yeah, so how do we get EF? EF, ED, and FD versus CD, DB, and BC. Yeah, I'm pretty sure this can be turned into trigonometry. I just don't know if I want to do it. So sine of A is sine of B plus C, and EF is, yeah, let's see. Yeah, because EF, ED, and FD can all be written in terms of the end radius and the sines of the angles. So actually, maybe that's not such a bad idea. So you know what? I'm going to try this. So I'm going to label the midpoints of each of those segments. So if I call I, J, and K the midpoints, so EF is 2, so HF over the end radius is equal to cosine A over 2, right? Let's see. So I'm just gonna, I don't usually do trig, but let's see. I might be able to do something here. So, I mean, really, we can handle FD over BD. That's just, so FD over BD is just twice the cosine of 90 minus, that's just twice sine B over 2. So we have a 2 sine B over 2, 2 cosine B over 2, and then a C, and then a BC over EF, which yeah, I'm going to spend a little bit longer on this, but then I might move on. This is a little harder than I thought. I only picked 2 others, but I might also do a third after that. I'll spend 10 more minutes on this one, and then I'll move to the next. Yeah. All right, I'll skip to the next one.